we need to talk about transformations. Alright, so when we talk about transformations, we are starting from that basic idea of A, which is the vertical stretch or shrink, and also when A is negative, it is a flip. We have our H, which is the horizontal shift. Remember, vertical is up and down, horizontal is side to side. And remember that this is going to be the opposite sign. And K is our vertical vertical shift. No tricks with that one. So for linear, if we think of y equals a times x minus h plus k. This is actually just a different way of writing point slope form equals m times x minus x1. Right, so if we take our point slope form and switch it around, then we have our okay, so then A is our slope. In addition to all of this, it's also, we call it our slope, and yeah, okay, and then let's see, quadratic. Oh, I forgot, we also looked at absolute value. That was the other one. Absolute value. So we had y equals a times the absolute value of x minus h. Oops. Oh my goodness. I'm having a day, guys. Plus k. Okay. Remember that A tells you the steepness of the sides. Right, so here our shape is like this. Here our shape is this V shape. So A tells us the steepness of the sides. It's like the slope of the positive side, and then you reverse it, or it's the opposite for the other side. And then our vertex is at HK. Okay. Okay. Quadratic. We have y equals a times x minus h squared plus k. And again, A is gonna determine how fast we go up. It's not as direct as here because this is more close to the slope, and here it's going to have that curve to it. But generally speaking, it's going to tell us, is it a tall skinny parabola or is it a short squat parabola? And then our vertex is at H. And then we have exponential. Y equals A times B to the X minus H plus K. And then we have our log. Y equals A times log base B of X minus H plus K. So our H and K are gonna shift things around for both of these. They're gonna just shift those points. So if you start with your parent function from the base, you always, for exponential and log, you just match the base for the parent function. So here the parent is y equals base to the x, and here it's y equals log base b to the x with those bases the same. And then once you kind of find your key points for that, you can shift them left and right, up and down, and then do some stretching. Yeah, let's see. So then let's talk about the table. If we use our 4-column table, this is x and this is y of the parent function. So for each of these, you're going to go with the parent function, right? So here it's y equals x, here it's y equals the absolute value of x, here it's y equals x squared, and then these, again, your parent function is going to vary depending on the base of your exponent. And then this transformation is always a times y plus k, because these are the things that affect it vertically. And this transformation is going to be x plus h, remembering that h is the opposite. So here it's negative h and here it's positive h, so it's going to be the opposite. Yeah, so let's do an example. Make sure I'm centered again. Okay, so let's say y equals 3 times x plus 2 squared minus 7. I'm just making stuff up now. Alright, so then for my table, I'm going to start with my xy, and remember my parent function is y equals x squared because this is quadratic. So for parabolas, I like to just kind of, oh my gosh, this is what happens when I talk and write at the same time. I like to just start with the center numbers here. Keep them small and simple. So negative 2 squared is positive 4, negative 1 squared is positive 1, 0 squared is 0, 1 squared is 1, 2 squared is 4. And then here I have my transformation. So if it's a y plus k, then this is going to be a equals 3, h equals negative 2, and k equals negative 7, right? Remember that h is the opposite. So this is going to be 3 times y minus 7. So 3 times 4 is 12, minus 7 is 5. 3 times 1 is 3, minus 7 is negative 4. 3 times 0 is 0, minus 7 is negative 7. 3 times 1, this is repeating. So we have that symmetry. And then on this side, it's going to be x plus h. So x plus h, remembering that it's the opposite sign, so in this case it's going to be x plus negative 2 or minus 2. So negative 2 minus 2 is negative 4, negative 1 minus 2 is negative 3, 0 minus 2 is negative 2, 1 minus 2 is negative 1, 2 minus 2 is 0. So we can see that all of these points have shifted left by 2, and all of these points have shifted down 7, but also have been stretched by a factor of 3. So the overall parabola is going to stretch and move. Okay. Yeah, so there's an example. Let's do an example of an exponential one. Y equals, let's go 1/2 times 3 to the x minus 1 plus 4. Okay. So here my parent function, I have to look at that base. So it's just y equals 3 to the x, and this is going to be, let's identify again, a equals 1/2, h equals positive 1, it's the opposite, and k equals 4. Remember, the reason that it's the opposite is because this negative is actually part of the formula. So if it's x minus h, then the h is just what comes after the minus sign. Okay, so then we've got my ay plus k, so this is 1/2 y plus 4, and I have my x plus h, so this is going to be x plus 1. Okay, for my x values, I still like to just have negative 2, negative 1, 0, 1, 2. Keeps the number simple. I'm going to start actually at 0, so anything to the 0 power is 1, 3 to the first power is 3, and 3 to the second power is 9. And then we know negative exponents are the inverse, or the fraction, flipped it. So negative 1 is going to be 1/3 because it's the inverse of 3, and negative 2 is going to be 1/9 because it's the inverse of positive 9. Okay, so now, I gave myself a lot of fun here with these fractions. Alright, so let's start with x. So negative 2 plus 1 is negative 1, negative 1 plus 1 is 0, 1, 2, and 3, just adding 1 to each of those. And then here, gonna need some space to do this. 1/2 times 1/9 plus 4. So this is 1/18 plus 4. So 4 and 1/18. And then we have 1/2 times 1/3 plus 4, which is 1/6 plus 4. So 4 and 1/6. 1/2 times 1 plus 4 is 1/2 plus 4. So there's 4.5. This is where it's going to get tricky. 1/2 times 3 plus 4 is 3/2 plus 4, which is 1 and 1/2 plus 4. So this is 5.5. You can see this is where it starts going up more steeply. And then right down here, 1/2 times 9 plus 4 is 9/2 plus 4. 9/2 is 4 and 1/2 plus 4. 4 and 1/2 plus 4. So that's 8.5. 8 and 1/2. Okay, so you can see so actually, before we do anything else, I want to go back and think about the idea of domain and range with these. So here, for my parent function, my domain, my vertex rather, is here at 0, 0. And so my domain is there. And then here, I've shifted it, so my vertex is now at -2, -7. And I'm just sketching quickly. So my domain is all real numbers. And my range is y is greater than or equal to -7. Looking from that vertex up. Here, if I'm starting with this, and then it's gonna shift up. Sorry, I forgot to do this. And then it's gonna shift up, but flatten out a little. So it's gonna be more like this. So my asymptote is at 4. That's the equation for my asymptote. So now my domain is still all real numbers, but my range is y is greater than 4. It's above 4, never quite touching 4 or going below 4. All right, so there's some examples of transformations.